So here our class is Computer Organization Module 1 Lecture 3. Now here first the type of the instructions. As I have already told you that there are several types of instruction in a system. That means when we are writing any program, we are writing actually the set of instructions. Now what are the type of the instruction that can be executed in an organization, computer organization? So first is the arithmetic operation, second comes the memory operation, third comes the comparison operation, and fourth the control instruction. These are mainly four types of instruction. Using these four type of instruction, we can program, we can write any algorithm. Okay, that means these are basically the four. Yes, there may be more than this instruction, but if we broadly divided, these are the four type of instruction which is available in a computer architecture. Clear? Now see the instructions. First comes the arithmetic instruction. Now what is arithmetic instruction? In the arithmetic instruction, in the arithmetic instruction, the set of the instruction are used for arithmetic or logical operation. From the system, you know that whenever you are doing any program, it may be data structure or it may be some mathematical program, you require some arithmetical operation or you require some logical operation. Clear? So this type of instruction, arithmetical instruction, it can do arithmetical operation, and as well it can do the logical operation also. Now see here, these are the different types of example of arithmetical instruction. Add means we are adding two numbers. Multiplication, that means we are multiplying two numbers. Then subtraction, we are subtracting one number from the another. Or not and AND, these are the Boolean operation. That means these are all the logical operation. So these are all the examples of arithmetic types of operation. See, in one example I have given, that is add A comma B. That means here two values which are stored into the register A and which is stored into the register B will added up, and the final value will be stored into the register A. So this is one example of arithmetic instruction. Now memory operation. Now what happens in the memory operation? I have already told you that whenever we want to execute any program, the program has to be stored into the main memory or RAM. But inside the CPU, there are the different set of register. I have told you that is called the general purpose register. So when we do any arithmetical or logical operation, we have to take the data or the instruction from the main memory to the register which is within the CPU. So that operation is actually done by the load. When I are talking about the load, that means data will be transferred from the memory, that means the main memory, to the register. That is called the load operation. Clear? And another is the store operation. Store operation is just the reverse of the load operation, where the final output or the final data will be stored from the register to the memory. So that is called the store operation. Now see here I have given two examples. One is load A M1000 and another is store A M1004. What is the meaning of that? First instruction, load A M1000. The meaning of this is, here the data which is stored in the memory location 1000, that means 1000 is the address of the memory location, will be loaded into the register A. Again I am repeating, the data which is stored into the memory location 1000 will be transferred to the register A. This is the meaning of the load operation. Clear? Then comes the store operation. Store operation means just the reverse. Here the data which is in the register A will be stored into the memory location whose address is the 1004. Clear? And this 1004, remember, here I am written in the decimal, but most of the books you can find it is written in the hexadecimal code. Clear? So store A, that means the data which is stored into the register A will be transferred to the memory location 1000. So this type of load and store These are called the memory operations. Clear? Now then comes the comparison. Now comparison operation means, always remember that when we are writing any program, suppose you are writing any high level program, we always use some comparison operation. What is the comparison operation? Suppose if else function, if this a equal to b, do this statement, otherwise do that another statement. So this type of operation, this is very essential for any types of programming. So these are called the comparison operation. Always remember, without if else statements, it is very difficult to write any program efficiently. We must, this is a basic thing, that we require the if else statement in a programming language. Otherwise it is very difficult to write any program. Here also in the assembly level program, we require this type of comparison. Clear? Here the comparison, see here the first example I have shown here, that eq, that means equal to, that means if the data is equal to that, it will return 1, otherwise it will return 0. Clear? That means, see here, if a equals b, then it returns 1 and otherwise returns 0. Why 1 and 0? You know that computer only understand the binary value. Here 1 is the true and 0 is the false. When you are doing any high level programming and you are using, suppose if else statement, there also the output value is true. If it is true, then my output will be 1, otherwise it will be 0. That means here true is 1 and false is the 0. So eq means if eqab, that means if the value of a is equal to b. Similarly, neq, if I write here neqab, that means if the value is not equal to, then it will return 1, otherwise it will return 0. That means this is just the reverse of eq. Clear? So this is another type of instruction which we use in any assembly level program, or which we require to programming any algorithm in a computer architecture. Clear? Now the last type of operation, that is called the control operation. This operation is also very important. Clear? Control operation means when you want to change the sequence of the program. Example, in the high level language I am telling here, suppose we want to add, I am writing a program for I is equal to 1 to 10, p is equal to p plus 1, end of the for. That means here the loop will go for 10 times, and suppose the initial value of p is 0, then after one iteration it will be 0 plus 1, another iteration it will be 1 plus 1, another iteration it will be 2 plus 1, then 3 plus 1. In this instruction, what is the condition? Condition is for I is equal to 1 to 10. That means the value of the I, it should be varies from 1 to 10, not less than 1, not more than 10. Clear? So this is the condition, and using that condition we are jumping to one position. That means after doing p is equal to p plus 1, we are not coming out from the loop, because still the condition is satisfied, because I is less than 10. Then we will again go back to the first position, again we will do p plus 1, again we will return back and do the p plus 1 until the value of the I is 10. That means though there are different sequential address, we are accessing the same block of the address which is in the for loop until the condition is satisfied. So here the for is actually the jump instruction. We are jumping from one address to the another address location until the condition is satisfied. This is called a conditional jump. And there is another type of instruction that is called unconditional jump. Unconditional jump means there is no condition. That means suppose I have written here while within bracket 1, and suppose p is equal to p plus 1 and end of the while. What is the meaning of that? When the value of the while is true, as you have already written it is 1, it is always true, it will go for the loop and it will go for infinite times. Clear? Because here you have not given any condition, you have only given that it is always true. Clear? So this is called the unconditional jump instruction, but very careful, this type of instruction may bring the computer to the halt because it may go to the infinite loop, because you have not given any condition, it may go to the infinite loop. Clear? So in the assembly level language, here also we use the different types of conditional and unconditional jump instruction. Clear? See here. First example, I have written here JMP 1004 HEQAB. What is the meaning of that? Meaning of that is the control will jump. EQ, I have already told that EQ means whether it is equal to, whether the value of A is equal to B. That means when EQ value of A is equal to B, the program will jump to the address location 1004 hex code, in the hex code. Clear? That means if the condition EQ AB, this condition is true, that means if it is 1, the program, the control of the program will jump to the 1004H hex code. Clear? But if it is not true, obviously the next instruction will be executed. Next means after the jump, whatever may be the instruction, it will be executed. So this is called the conditional jump instruction, because the condition you have written here, EQ AB, this is a condition you have written. Based on this condition, the program will jump to the another location or not. Okay. But suppose you have not given any condition here. You have just written JMP 1004. What will happen in this case? In this case, whatever may be the value of A, B, it will not bother about the A and B, or it will not check the value of A and B. It will jump to the location 1004 hex code in the main memory. Clear? That is called a unconditional jump instruction. In the assembly level language, we use both the conditional and unconditional. Okay. Then another is BEQ 1024. This is also same type of instruction. This is BEQ means branch equal 1024 AB. BEQ means branch equal. That means if here I have written the code, if A is equal to B, clear, it will jump to the location 1024 hex. Clear? That means if the condition is satisfied, that means it is true. Clear? Here we don't have to write the EQ, because BEQ means the whole branch if A and B is equal. Clear? Otherwise, if it is not equal, that means if this condition is false, the PC will be PC plus 1. What is the meaning of that? In the previous class, I have told you what is the function of program counter. Program counter stores the next instruction to be executed. Clear? But here you are changing the path of the execution depending on the condition. That means if A and B both are equal, the new address of the PC will be 1024. Clear? That means machine will start execution from this address. So this is the address of the instruction. Otherwise, after BU2, whatever may be the instruction, it will be executed. That means suppose this address of the BEQ is 100. That means next address will be 100 plus 1, that means 101, and the value of the PC will be 101. If this condition is satisfied, there will be new value of the PC. If not satisfied, the PC will execute the next instruction after BEQ. Clear? So this is called the control operation. So these are the 4 types of operation we use actually in the computer organization. Now comes the different types of cycle. Okay. Now when we are talking about the instruction, always remember instruction can be divided into mainly 5 parts. Here I have written. Clear? First one is the instruction fetch. I will tell the meaning, what is the meaning of different thing. Next one is the instruction decode, then memory read, then EX means execution, then MW means the memory write. Now, what is the meaning of these different types of parts in a single instruction? Remember, this is the part of a single instruction. Clear? When the instruction is written in the memory, and when CPU wants to execute the instruction, first it has to read the instruction. Clear? Suppose you are given a question to solve, first you have to read the question. Similarly, processor has to first read the instruction from the memory. This is called the instruction fetch. This part is called the fetching of the instruction or instruction fetch. Clear? Next come instruction decode. Decode means processor have to find out what is the meaning of this instruction. In the last class, I have given you that for each instruction there is a opcode. Clear? That means processor has to find out from the opcode what is the meaning of the instruction. That means suppose you are given a question, you are reading a question, that is called the fetch. You try to understand the question, that is called the decode. Similarly, processor will try to understand what is the meaning of the instruction, this is called the decode. Then comes the memory read. If in the instruction there is any memory part or register part, you can tell, processor has to read that part. Clear? That is called the memory read operation. That means processor will read the content in the operand. This is called memory read operation. Then comes the execution. Processor read the values, then it will do the execute the value. That means whether it may do any arithmetical operation or logical operation. That is called the execution. That means suppose addition, it will add two numbers. The final addition is called the execution, and its execution is actually done with the help of the arithmetic logic unit. Clear? So this part is called the execution. After execution, what will happen? After execution, their last part is called the memory write. Whatever the result processor stored into the accumulator or the general purpose register, it has to store that result into the memory. That means the main memory. That is called the memory write operation. Clear? So these are the 5 parts in any instruction. Now here in the 5 parts, see, I have given here, I have make read 3 parts, IF, ID, EX. What is the reason? Reason is that these 3 parts are mainly the parts which actually occurs in an instruction. In some instruction, there may be memory read, there may be memory write, or in some instruction, there may be no memory read or no memory write. But in instruction, there is always exists 3 parts, that is the instruction fetch, instruction decode, and execution. So we will discuss today about the 3 parts. Clear? These are the main parts in instruction. Here I have written fetch, decode, and execution are mostly important. Fetch. As I have already told, read the next instruction from the memory into the instruction register. I have already told that instruction register is a special purpose register where the actual instruction is stored. And as it is a register, it is within the CPU. Clear? This is called the fetch. And here, read the next instruction from memory means, remember that this is the main memory or RAM. Clear? That means the data or instruction from the main memory will stored into the instruction register. This is the fetch operation. Clear? Decode. Decode means, as I have already told, find out the meaning of the instruction. What is the meaning of the, suppose someone written add AB. Processor has to find out from the opcode what is the meaning of the instruction, because using that meaning, it will generate the different types of control signals. Clear? So this is called the decoding the instruction. Then last, obviously, the execution. In the execute, it will implement the operation given in the instruction. That means it may be addition, division, subtraction, multiplication. This type of operation actually done in this phase, in this cycle, that is called the execute cycle. Clear? Now, this is the fetch cycle. See what happens in the fetch. To start the processing, CPU needs to fetch the first instruction in the program from the main memory. Clear? I have already told that the instruction and data is stored into the main memory. Whenever processor want to execute the instruction, it has to take the data from the main memory. Always remember, processor directly cannot take the data from the secondary memory. It has to be stored into the main memory or RAM. Clear? Now see, what are different types of micro operation related with the fetch. Now the question is, what is micro operation? Whenever we are doing any instruction, we are running any instruction, processor is running any instruction is actually divided into three. I have already told: fetch, decode, and executed. This fetch instruction is also divided into several micro operations. Clear? Micro operation is nothing but the register transfer operation, where data from memory to register and register to register is transferred for particular type of operation. Clear? So first, see there are the three micro operation is done in the instruction fetch cycle. Remember, this instruction fetch cycle is common for all the instruction. That means whenever you have written any instruction, processor has to fetch the instruction from the main memory. So instruction fetch consists of three micro operations. I have written here 1, 2, 3. First one is the PC data will be transferred from PC to MAR. That means program counter to memory address register. I have already told memory address register, program counter, these are the special purpose register which are used for the programming, but it is not available to the programmer for writing any general data. That means this is not general purpose register. So first micro operation is program counter. Why? Program counter contains the next instruction to be address of the next instruction to be executed. So that address from the program counter register will transfer to the memory address register. This is a one type of special purpose register. Clear? In the second micro operation, what happens? After completion of this second micro operation, MAR, see there are two brackets are given, MAR to MBR. The meaning of that is, this bracket meaning is PC will transfer the address to the MAR. Clear? And the content of the address. What is the content of the address? Content of the address is the instruction itself. Clear? That means suppose PC transfer the 1000. 1000 is the address of the instruction, not the instruction. Clear? So then in the second micro operation, the actual instruction has to be transferred from the MAR. Bracket means the content of the address. Content of the address is the instruction, and that instruction will transfer to the MBR, memory buffer register. Clear? This will hold the actual data. Clear? So MAR will contain the address of the instruction, and the actual instruction will be stored into the MBR. Clear? MBR holds the actual instruction. Now from the MBR, the data will be stored to the instruction register. Clear? Why? Because in the instruction register, it will be ready for decode. That means decode cycle only execute in the instruction register. The registers are made in this way. And in the same time, in the same micro operation, PC will be incremented to PC is equal to PC plus 1. That means after the fetching of that instruction, it will want to fetch the next instruction. So it will be incremented to PC is equal to PC plus 1. Here, one thing I want to told, if you are using any branch instruction, then PC may not be PC is equal to PC plus 1. It may be some another address, as I have told you, depending on the condition. Clear? So this operation is for the instruction fetch, and this is common to this micro operation is common for the all type of instruction. In type of instruction you have written, it have to go through this micro operation. This is called the fetch cycle. Clear? After that comes the decode cycle. Clear? What is decode cycle? Decode cycle means here the instruction which is stored into the instruction register will be decoded by the CPU. Decoded means you have to find out what type of instruction it is. Last day I have shown you the opcode. Opcode means add AB. Clear? Suppose I am giving you the example add AB. That means we are adding the values in the two register A and B and storing into the register A. In this case, add is a opcode, and AB, that means register A and register B, these are called the operand. Operand may be register or the memory. Clear? So from the opcode, we have to find out, processor has to find out what is the meaning of the instruction, whether this is addition of the instruction or multiplication or division, it will find out. So this is called the decoding of the instruction. Based on the decoding of the instruction, control unit will generate the control signal such that the different components of the architecture is activated to carry out the particular operation. That means suppose add AB. In this case, we require the arithmetic logic unit. That means ALU, this part will be activated by the control unit if it can decode the instruction. Clear? So this is called the decoding of the cycle. This is called the decode cycle. Clear? Now execute cycle. Execute cycle means obviously the operation. Remember that execute cycle also consists of a set of micro operation. Clear? Here I have given the example how one instruction can be executed in the execution cycle. Remember, when I am talking about the execution cycle, the fetch cycle is already happened. Fetch decode is already happened. It is now will do the execute. Clear? So here the LDA X. Here LDA means contents of the memory location will be transferred from X. X is the memory address. I have not written the address, original address. X to the AC means the accumulator. Assume that we are talking about an accumulator based system. So LDAX means the data from the address location X will be stored into the accumulator register. See, this is the execution cycle of this. I have already told that instruction register will store the whole instruction. Clear? After decoding, what will happen after decoding? IR address, that means the address part of the instruction. What is the address part? Here X is the address part. That address part of the instruction will be transferred to the MAR by this micro operation MAR, memory address register. Because this is the address part, X is the address, so it is stored into the special type of register MAR. Clear? After MAR, again there is a bracket, that means the contents of that particular address. That means content of the address X. Suppose address X contains the value 2. That means this 2 will be transferred to the memory buffer register. Clear? Here the address will be transferred to the MAR. Content of that address within bracket means content of the address will be transferred to the MBR, that means the memory buffer register. And from the memory buffer register, the value will be transferred to the accumulator. So here see what is the instruction LDA X. That means the data from the address location X will be stored to the accumulator. See here, that is the accumulator AC. That means the memory data from the memory buffer register will be transferred to the accumulator. So execution is complete for the LDA X. Clear? Now add X. This is the another type of instruction. Clear? Here also instruction is already fetched, it is already decoded. Now it comes to the execution cycle, or it enters into the execution stage. What happens? What is the meaning of add X? First see the meaning. It will add the number in X. X means the memory location with the accumulator. Accumulator is a special purpose register, special type of register, and store the result in the accumulator. This is the meaning of the add X. As it is an accumulator based machine, last class I have already told you, you don't have to mention the particular name of the register. Clear? So here first again the address part, because this is X is the address, will be stored into the special purpose register, that is the MAR. Clear? And the contents of the MAR here, contents of the MAR, that means the content of the address X will be transferred to the MBR, memory buffer register. MAR is memory address register. Remember, memory address register, you must go to the previous class where I have given the meaning of the different types of register. Memory address register contains the address. Memory buffer register contains the actual data. Clear? So memory, it is stored, transferred in the memory buffer register. In the third operation, the memory buffer register will be added with the data into the accumulator, and the result will be stored into the accumulator. So ultimate meaning is the value which is stored into the address X will added up to the data in the accumulator, and the data will be stored into the accumulator. So this is the execution cycle. Clear? So this is the last slide. So here, what is the gist? In short, I can tell you that we learned about the different types of instruction here, and we learned about the example, what are the different types of example of the instructions, and we came to know that for execution there are mainly 5 parts: instruction fetch, instruction decode, memory read, execution, memory write. Some instruction may not contain memory read and memory write operation, but most of the instruction contains memory fetch, decode, and execution. What is memory fetch? Memory fetch means here we'll fetch the instruction from the particular address. Decode means processor will decode the instruction. It will find out what is the meaning of the instruction, why it is addition, logical operation, or it is some branch operation, all types of operation. Okay, logical operation, branching operation, conditional operation, all type of operation is decoded here. Last is the execute. Here the original execution is done. So these are the fetch, decode, and execution cycle. Clear?